As we enter into our menopausal years, we begin thinking a lot about aging and how can we slow it down? How can we preserve our skin, our heart, our brain, all of our other organs? Well, there's something that might help us with this, and it's called, now forgive me, I'm not going to pronounce this right, nicotinamide adenine dinucleotide, which we'll just say NAD, which I'm sure many of you have heard of NAD and not what I just said. You can see why it's been shortened to NAD. Our guest today is a bit of an NAD expert. Dr. Nichola Conlon is a scientist specializing in the study of cellular aging. After a career in drug development, Dr. Nichola founded Nuchido Laboratories, driven by her belief that cutting-edge science should not lie hidden. Dr. Nichola is on a mission to democratize science and has a skill for translating and presenting advanced science in a way that helps to educate and support people to take control of their health. Dr. Nichola is an expert in cellular health with a particular focus on NAD+, the science of aging well and helping people to reverse their biological age, which we all want to do. So welcome, Nichola. I'm so happy to have you here.
Hi, Karen. I'm really excited. I think we're going to have a great chat. And yeah, you did a really good job at pronouncing it, actually, and even attempting to pronounce it, because many people just don't even try. But, one of the top questions that I get is, what does NAD stand for? And I always say, okay, it stands for nicotinamide adenine dinucleotide, but you're never going to remember that. So it's just NAD.
Well, you make it sound a lot more eloquent than what I kind of butchered it just a little bit, but I tried. You're right. I put my efforts in, and we'll just go with NAD now. But so I heard about you from a mutual friend, Zora, and she was on my podcast a couple months ago, and we kind of touched in a little bit about NAD, and she was like, "Oh, you just have to get Dr. Nichola on your podcast." And so luckily she connected us, and I'm so glad she did. I loved the podcast that you did with her. It was so educational. So I'm really excited to bring this information to my audience because, as I said, we are all looking for the magic bullet or bullets that can help us to, keep our youthfulness and reverse the aging that starts to happen in midlife to all of us. So let's start with just really simple. What the heck is NAD?
Yeah, absolutely. Well, I always say NAD is probably the most important molecule that most people have never heard of.
Wow. Yeah.
And that's because if we didn't have NAD in our cells, we would literally be dead in 30 seconds.
Wow.
Yeah, it's just so important for many critical reactions in our cells, around 300 different chemical reactions that are going on all of the time inside our bodies. But I guess to keep it simple, the two things that NAD is most famous for is firstly energy production. So it's part of the pathways in our cells that literally take our food and convert it into the energy that all of our cells need to function. And this takes place in tiny little energy powerhouses in our cells called the mitochondria. And they're like the energy power plants, and literally their fuel is NAD. So NAD is so important for energy production. And the second thing that NAD is really important for is repair. So again, NAD acts as kind of a fuel to drive a lot of the repair processes that are going on inside of our cells. So things like repairing any damaged parts of our cell, repairing any damaged DNA. NAD is driving that repair and making sure that it happens. So as a general rule of thumb, all that you need to remember is that when NAD is high, you have lots of energy production and lots of repair. And when NAD is low, energy production gets turned down and your repair also gets turned down.
Right. Why has there been this surge of popularity when it comes to NAD? Like, is this something that we're just kind of figuring out in the last decade, or has it always been around? It's just now kind of people are getting more into it, because now I feel like everywhere I turn, I hear about NAD. Like I go into my naturopath office and it's all about NAD IVs and NAD this and NAD that. And it's like this miracle thing. And even all the peptide companies, they all sell NAD in a bottle. And there's a bazillion supplements with NAD. And so has it been around for a long time? I mean, no, it's been around forever, but this whole surge, where's that coming from?
Yeah. So, about a decade ago,
Okay.
As scientists, we were still quite unsure as to could we really address aging at the cellular level. Okay. So for a long time, everyone's just thought of aging generally from the surface. We talk about aging from an external point of view, about how we feel, how we look, but we never really fully understood what was actually happening inside of our cells to cause the aging process. But ultimately, everything that we know as aging is starting not on the surface, but inside of our bodies at the cellular level. And over the past decade, scientists have begun to really understand which cellular processes are causing the aging process. And we refer to these as the hallmarks of aging. So it's like 12 key things that are going wrong at the cellular level to cause the aging process. Okay. And obviously, once people have worked out, okay, this is what's happening at the cellular level, everyone was like, okay, so how can we fix these things? And this is where NAD started to come about. It seemed that NAD was this key molecule that almost sat in the middle of all these different root causes of cellular aging. And if NAD went down, all the hallmarks of aging got worse. And if NAD went up, they all got better. So this is why suddenly there's been a huge interest in NAD, because NAD has been known for a very long time, since we first discovered as scientists, over 100 years ago, that how we produce energy, it's been known, but it was never known in the context of aging. Oh, and that is why we've suddenly had this big buzz around it. Because what's been found is that when we are young, we have very high levels, but as we get older, our NAD levels decline. And as we've just mentioned, if you have low NAD levels, it means energy production gets turned down and also repair gets turned down, which means at the cellular level, we don't function as well. All those hallmarks of aging start to get worse, and we start to suffer from damage at the cellular level. And this ultimately manifests as a lot of the signs and symptoms that we see and feel as part of the aging process. So scientists were like, okay, if we've got this molecule that's when it's very high when we're young, it's keeping energy high, it's keeping repair high, but when we get older, it goes down and all these things get, switched off, then why don't we just not let it decline? Like, can we keep it topped up? And would it keep energy production turned on? And would it keep repair turned on? So scientists began to do a lot of experiments, at first in cells and then in humans, looking at, could you boost NAD levels? And more importantly, if you boost NAD, what are the benefits? Mm-hmm. And they found that by simply increasing levels of these molecules in our cells, it massively addressed a lot of the common sort of signs and symptoms associated with aging, not only at a cellular level, so, looking at cells and seeing they look younger and healthier, but actually at a body level, addressing multiple age-related diseases, increasing what we would call our health span, which is how healthy we are, or the proportion of our lives that we live in good health, as opposed to our lifespan, which is just how long we live, which unfortunately is not always in good health for the duration.
Yeah. When you say like the 12 hallmarks of aging, can you tell me some of what those are?
Yeah. So, I mean, we could do a whole podcast.
Yeah, I know. Those. So that's why I said, just maybe just throw a couple.
Yeah, just to briefly summarize some of the more common ones that people may have heard about. A major one is DNA damage. So we know that in our cells, we have the DNA. It's the blueprint for everything in our bodies. And over time, this becomes damaged. And the more DNA damage you have in the cells, ultimately, the faster you are aging. So what we see is that if you speed up DNA damage, you age quicker. If you slow down and repair DNA, you age slower. Now, where NAD comes in is that for this particular hallmark, NAD powers these DNA repair enzymes. So these are like little warriors almost sitting in our cells waiting for any little piece of DNA damage to pop up, and then they come along and fix it before we even know that it's a problem. And when we're young, they have lots of NAD to power them, and we don't even realize we've had any damage because it's fixed before it's even a problem. But as we're older, NAD goes down. DNA repair enzymes, they just don't work as well. They're slow, they're inefficient. DNA damage starts to build up, and this causes a lot of the aging process in cells. So that's probably the most famous hallmark.
Yeah. You know, looking at it from, like, I always look at things from that, like, kind of hunter-gatherer type view of why do the things happen in our body, on that level? Like, why is it that our body starts to be deficient in NAD? Like, what was the purpose of that? And I just, you know, same with hormones. I work a lot with hormones and bioidentical hormone therapy, and you know, like, why is it that we lose all of our hormones, and that loss of hormones drives so much disease and aging? And now NAD is reminding me of that. It's like we're getting lower and lower levels. And do you think it was a built-in mechanism to get us to die, basically, because the human race just couldn't keep going? We had to die at some point. So it's like your bodies, we're kind of we're trying to like stop that and hack our way through the aging process. But, you know, at a core level, that's probably the purpose behind losing it, is to get us to die. Do you think?
Well, do you know what? It's so interesting that you say you like to think of it as like a caveman type and, you know, side of like evolution, because when anyone asks me to explain anything to do with the biology of aging, I always say that you need to look at it through the eyes of evolution. Nothing in most of biology, and definitely not in any of aging, makes sense unless you look at it through the eyes of evolution. Okay.
Yes.
And what I mean by that is that if you think about it, our bodies, as crude as it sounds, are designed basically to be a shell to house our DNA so that we can find a mate, reproduce, and pass our DNA on to the next generation. And as far as evolution is concerned, that is what it has designed us to do. It has not designed us to be doctors, scientists, podcast hosts, whatever. It's designed us literally to reproduce. And this means that everything in our bodies is designed to try to fulfill this purpose. And when we are young, the body has to do everything it possibly can to keep our DNA protected and in good health, because it's the DNA that it wants to pass on to the next generation. So our bodies are designed to invest a lot in repair processes to protect this DNA and make sure that we get to childbearing age, are able to reproduce and pass this DNA on. Now, unfortunately, a lot of those processes that we've just discussed, like DNA repair enzymes and things like that, that are happening all the time inside of us, are very, very energy consuming. It means when we're young, the body's like, okay, it's worth investing all this time and energy and effort into protecting ourselves and protecting our bodies because we've got to fulfill the purpose. But after childbearing age, or after a certain age, it was unlikely that we were probably going to be alive still. You know, we should have fulfilled our purpose. And if we hadn't, then we were probably going to die soon, because unfortunately, our average lifespan was around age 40. We were definitely not living till our 80s.
No.
So everything in our biology is designed for us to be good at being young, but we were never, ever designed to be good at being old, because we would never reach old age. So why would evolution select for anything that would make us good at being old? And over the last even, couple of 100 years, our lifespan has suddenly rapidly increased. We've gone from being very lucky if we reached age 40 to now being like pretty much certain, depending on where you live in the world, to get to around 70, 80. And we are not designed for that.
No.
And this is a problem. And this is when I talk about the difference between lifespan and health span. So we have these long lifespans now that modern, sanitation, healthcare and things have given us, but we don't have the health span to match, because a lot of our biology is designed to help us when we're young, but can actually backfire when we get older. So a very classic example of this is another hallmark of aging called senescence. I just don't know if that's anything you've ever come across before.
I have, but you can explain it, because I'm sure there's a lot of people that haven't heard that.
So senescent cells is a really interesting thing. Sometimes they're called zombie cells. But basically, when we're young, if we get any damage in our cells, usually it's repaired. But sometimes a cell can be so damaged that the body almost like sets off an alarm bell going, oh dear, this cell is a write-off. It's beyond the state of repair. We just need to stop it from replicating in case it becomes cancerous. So what the body does is, instead of, completely getting rid of it and recycling it and removing it from the body, it just shuts it down. So it puts it to sleep. And so these are often called sleeping or zombie cells, these senescent cells. Now, when we're young, that's brilliant, because it means very quickly, if there's anything going wrong in any of our cells, our body just goes click of the fingers to send it to sleep. So that's great, because it prevents us from getting cancer when we're young. Obviously, people still do get cancer, but in general, it prevents that. And it means that we'll get to childbearing age and fulfill our life's purpose, our evolutionary life's purpose. And what happens is that's fine when we're young, because those cells just sort of sit there. There's not that many of them. But now that we're living to age 80, it means that by the time we're like at more advanced ages, actually a lot of our tissues are full of these zombie cells, and they're accumulating. And what's now being found is that actually they don't just sit there quietly, they actually secrete a lot of inflammation. And inflammation is really bad when it comes to aging. It's another hallmark of aging, chronic inflammation. So all of these cells are sitting there in our tissues, first of all, not performing their function. So in like our skin, for example, they're sitting there in our tissues, making it stiff and loss of elasticity and things like that. But also they're giving off loads of inflammation, which is then damaging the cells around them and causing them to become senescent. So it's a very classic case of something that evolution has given us as a way to help us when we're young, that completely backfires when we're old and actually causes us problems. But we were never meant to live this long.
Yeah, exactly. Yeah, there's a lot of people that will say, when I'm talking on being interviewed for other podcasts or doing speeches or anything, that I always get, well, why should we replace our hormones? It's natural for us to go into menopause. And I'm always like, but it's not. We were never meant to live this old. So why not like give our body what it's looking for to help with the aging process, which in my world is hormones, but NAD is also a huge part of that. It's like naturally, evolutionary, we should be losing it. This is what's supposed to happen. That's what's natural. But we're living longer than ever before. So why not live quality life rather than, okay, here's your prescription for this and for this and for the inflammation and the heart disease and all the things that come from the hallmarks of aging. So I just see it the same way. It's like, this is another added thing that's going down to a very root cause of the aging process.
Oh, I completely agree. Our bodies are made to function with high levels of NAD, with hormones. Our cells function at the best and are designed to function under those conditions. But, as we've just been chatting about, we were never designed to live this long. So our cells are not designed to live without hormones. They don't suddenly change. And, there's not a real evolutionary reason other than we weren't designed to live this long.
Yeah. Our bodies have to catch up to 2023.
Yeah.
Like
And,
on the
and
inside.
I often say, which people like take a moment to think about, is that like aging as we know it today didn't actually used to exist. It's quite a
Mhm.
new thing,
Mhm.
because we never lived long enough to age the way we do today. If you went back 1,000 years or whatever, you would not be finding elderly people. Like they would, it's something, they would have had a disease or an abscess, died in childbirth, hunting, like, well, not 1,000 years ago, but
Yeah.
pretty much.
How is it linked to metabolic dysfunction and weight, like obesity and gaining weight? And because I know that when there's not a lot of energy, not just because you don't have energy to exercise, but that process can drive that, can it not?
Yeah. NAD is very intricately linked with a lot of metabolic dysfunctions.
Okay.
And it's actually pretty clever piece of biology is NAD. Because essentially what it does is it acts as like an intermediate, or it sort of relays information between what is going on in the outside world or our environment, and how our cells inside need to respond to, for appropriate adaptation to whatever's going on in our outside world. So for example, if you are doing a lot of exercise, or you are fasting, then what will happen is that is perceived by the cells as an energy stress. So it activates pathways in our cells that say, we don't have much energy coming in, or we're using a lot of energy. Therefore, we need to make sure our cells are well equipped to deal with this stress. So what they do is they actually switch on an enzyme that makes NAD. And NAD levels go up. And as NAD levels go up, we obviously get more energy made to compensate for this energy deficit. And then we also get repair switched on, so that our cells are equipped with all the tools they need to survive the period of stress, repair anything, recycle anything, and get through it. So again, looking back at evolution, this was brilliant because we weren't eating all the time. We were having to go hunting, going for long periods without any nutrition coming in. So this is why our bodies were designed to switch on their own NAD production. But nowadays, we're told that we need to have breakfast, lunch, evening meal. We need to have a snack in between. We can't possibly last more than 4 hours without eating. And usually a lot of people are sat down all day. We're not running around all day. We're not on our feet all day. So both of these things mean that our bodies and our cells are just like, oh, we have loads of energy coming in. Like, why do we need to produce any extra? So this energy stress pathways aren't activated. NAD production goes down. We don't get as much natural energy production. And also those repair pathways that are sitting inside our cells are just simply not getting activated like they were designed to.
Wow. Is there a tipping point where those things become a detriment to that production of NAD, in the sense of, when we look at it from an evolutionary standpoint, too much fasting, too much exercise will start to trigger other mechanisms in the body? For instance, thyroid levels will start to go down, reverse T3 starts to go up, which is like preserving your metabolism so that you're not burning up energy anymore. So there's a tipping point, I know, like hormonally, and what starts to happen if there's too much of that, where people, they get into fasting and they start fasting every single day. They're eating one meal a day because they hear it's so good for autophagy and it's so good for this and it's so good for that. And they get all these benefits. And then I see it start to reverse itself, and they start to gain weight. They start to feel really bad. Their hair starts falling out. Their menstrual cycle gets messed up. So is there a
Yeah.
tipping point with NAD as well, where it's like too much of a good thing is then turns to bad?
So with NAD itself, we are used to having very high levels. Like, it's not an abnormal thing in the body. And, you know, high NAD is correlated with, negatively correlated with a lot of health issues. So as NAD goes up, the health issues go down, or as NAD goes down, the health issues, a lot of chronic health issues go up. However, everything in biology is linked. Like, nothing lives in isolation. And this is a point that I always try to get people to think of, you know, and even just us talking about NAD today, although it's amazing, there's a lot of other things going on that all need to be considered. And when it comes to things like exercise and fasting, yeah, there is too much. And when it comes to how this will impact NAD, what you can see, especially through too much exercise, is increased levels of inflammation. And a lot of inflammation actually makes NAD go down. Because a lot of inflammatory processes actually eat up a lot of our NAD supply, and which then actually drives further inflammation. So it's a bit of a vicious cycle. So yeah, there is a balance, but exercise and fasting are the two best known natural ways, lifestyle factors, that will influence your NAD levels. Because what we know is NAD does decline in everyone. It declines in every tissue. It's been well measured. It halves around every 20 years. And this is from birth. So even by age 20, you've only got half the amount you were born with. By age 40, it's halved again. 60, that's halved again. So you see a real sharp decline. But whenever I'm talking about NAD, I never show a straight line graph. I always show a graph that kind of has lots of lumps and bumps and goes up and down. And that's because NAD and lifestyle are so linked. And there are lots of things within our lifestyle that will either slow down the rate at which NAD declines or speed it up. So I think it's important for people to realize that it's a mixture of just the way we are, but also our lifestyle.
And so when you say exercise and fasting are the two top things for our own, to get the own production of NAD going up, have they researched, how much exercise, what kind of exercise is best? How long should we be fasting? How often should we be fasting?
When it comes to exercise, there've been some pretty good studies, actually. It seems like the resistance training and high intensity interval training both seem to be good. And actually, the way that they work is the way they increase NAD is they switch on an enzyme in our cells that actually makes and recycles NAD. So I think in one of the key studies that was done, I can't remember the exact numbers, but I think in about 3 weeks of resistance training, it increased levels of this enzyme by about 50%. And that equated to, I think it was about 120% increase in NAD levels.
Wow.
So that's quite a lot for something that's not a huge deal for a lot of people to do. But yeah, that's the mechanism, that it increases levels of the enzyme that makes NAD.
Which is what's the enzyme?
It's called NAMPT, and that's an abbreviation because that is really really.
I won't ask you what that is. Yeah,
that you don't want to remember. But I guess a lot of people say, well, okay, so if you've got NAD and it's really beneficial, and why does it decline? Which we've talked about. But at a cellular level, something must be changing to cause it to go down. So what's been found is that there are two main reasons in our cells why NAD production seems to go down as we get older. The first is that our cells actually stop producing as much NAD. So in our cells, we have quite a cool little NAD recycling pathway, which basically every time some NAD is used in the cell, it gets broken down into its building blocks. And then this pathway picks back up the building blocks and recycles it back into the big fresh NAD molecule. And the key enzyme in that pathway is that NAMPT enzyme. And levels of that decline with age.
Okay, so we're not recycling it as best as we could.
Yeah, exactly that. Okay. In young cells, NAD just goes round and round and round. So as it's used up, more breakdown products, they're just recycled into more NAD, and it's a continuous pathway. So in older cells, that just doesn't work as well. the second thing is that in older cells, they've generally been around longer, they've got more damage, they've got more inflammation, and that means that the demand for NAD is greater. So, your DNA repair enzymes are working overtime, you've got inflammation going on, and all of these processes are just draining your NAD supply. So when you put the two together, you've got increased demand, and then you've got a reduction in the production of NAD, then this is why you suddenly start to see it really declining.
And why we get so tired, and we're always like, oh, I wish I had the energy I did as a kid, because then, you see these kids, they run around, they don't need breaks, they don't need to lie down for a little nap.
That is NAD. That is exactly,
okay.
and actually that is one of the best ways you can describe what NAD does. It's like when you see a child that's literally been up all night and then gets up the next morning after 2 hours sleep and then is, bright as rain and straight on and, off the go. And then the parent is like, I have had no sleep. I cannot function. How are they doing this? That is NAD.
That is NAD. And so how much should we fast to help with it, do you think?
Varies. So it's not actually that much as people think. So a lot of, when it comes to fasting, there's a lot of evidence that sometimes longer fasts are the ones that activate things like autophagy, which is the cellular recycling process. But actually NAD doesn't need as much of a long period of fasting. So you're looking at more the 12 hours plus. To start to see a change. And this is because NAD is something that is it naturally varies quite a lot throughout the day. So I think, as we age, it goes down, but actually on a daily basis, it's up and down all the time. So if I was to measure your NAD at different points through the day, it would be like a cyclical variation in NAD. And it's actually in line with our circadian rhythm.
I was going to ask that. Yeah. If it's circadian.
Yeah.
Okay.
So, so it seems that, after about, especially for women and men, it's different as well. From a lot of the research I've seen, I'd say, women don't seem to have to fast as long as men to activate many of the cellular pathways that are having the benefits. Whereas in men, they seem to have to fast a bit longer to get the same benefits. Again, probably, an evolutionary thing of our role as on the planet. So that's interesting.
So 12 hours, that makes me happy. So it's not like, oh, you got to fast for a week and then.
It's enough to activate something called AMPK.
Okay.
So AMPK is like the chief energy sensor in our cells.
Okay. So NAD. Okay. Got it. Okay. Now, and I know you've created a product, which is, I'm super excited for you to tell us why you created it the way you did. But let's first kind of go into the most common ways that people are getting NAD that seem to be kind of on a upward swing out there, we'll say. First, starting with IV NAD. Now, I personally have done that. Where I did a couple treatments of NAD IV with some of its precursors to help with long COVID. And so I didn't have long COVID, but I had the effects. I would just say I wasn't getting 100% at like a month after I had COVID. I was still tired, was still feeling run down. I did a couple of IVs, but then my body gave me like a hard no more. And that was enough. And it was enough to kick that out of my system. But I really felt like I couldn't do it anymore. And I didn't want to, my body was like, no more.
Okay. So 2 really interesting things. So the first is NAD and COVID. So studies have shown that when cells become infected with the virus, that they see a massive plummet in NAD levels. And then what the cells try and do is they try and switch on everything they can to try and get NAD back up. And one of the main things that the cells switch on in response to the infection is NAMPT. So that recycling enzyme, because they're frantically trying to replenish NAD. And we think it's a lot to do with the fact that NAD, COVID was activating a lot of inflammatory pathways that were draining the NAD supplies. So then the body was like, my goodness, we've got to, react and try and counteract this. And this is one of the theories about why, older people seem to have a worse time with COVID, because they are naturally starting from a worse position because their NAD is lower. And then all of a sudden the infection's taking it to levels where, it's even worse. And also, if you look at all of the categories of people that were really at risk, so people with metabolic disease, diabetes, things like that, again, all of these conditions are associated with lower NAD levels to start with. So there's still research, on going into that, but there were some very interesting papers at the time. Now, as for IVs, so they've become very popular.
Yes.
And, I think it's important to, whenever you're trying to treat something or you're trying to top something up, that you always look at why it's declining. So we've just discussed that we now know the reason that NAD is declining is because our recycling production isn't working, and also our inflammation is going through the roof as we get older. So the first thing to note is that NAD, just by putting pure NAD back in the system, it doesn't actually fix any of those problems.
Right.
Because once that NAD is in, once that NAD is in the cell, it's going to be used once, then it's going to be broken down. And then if your recycling's not working, where does that NAD go? And what we see happens is that actually the NAD is broken down into one of its precursors, and then it has to get methylated and excreted out of the cell, because cells don't like it when things build up. So you may, anyone familiar with the NAD space has probably heard about people saying, oh, if you're doing IVs or precursors, you need to take trimethylglycine to stop any methylation issues. And again, it's like crazy. It's like you're trying to fix one thing and making another thing worse, and then having to take something else to fix that issue. So I think a key thing is NAD in IV form or even precursors is not fixing that issue. When it comes to IVs, another thing is we need to understand that NAD is a big molecule. So cells do not let things in and out as they please. Anything that's big generally needs a special door or a special channel to get into the cell. And not many cells have an NAD channel. There's only known to be your heart and your brain cells that actually have a channel big enough to let it in. So an IV puts the NAD into the blood, but NAD does not do very much inside the blood. There's no DNA there. There's no mitochondria there. They are all inside the cells. So all of the evidence at the minute shows that not a lot of this NAD actually gets into the cells where it's going to perform its function.
Okay. Interesting. And would that the same thing go then, obviously, for just straight NAD oral supplements?
Never take oral NAD.
Okay.
So NAD is a very unstable molecule. If you had some NAD and left it out at room temperature on the bench, there would be no NAD left after an hour. It would be gone. It's very unstable. Orally, absolutely not. The gut, the stomach acid, it will just be absolutely destroyed. And this is where precursors came about, because people realized you can't use pure NAD. They realized the limitations of IVs and said, okay, what else can we do? So things like NR and NMN, they are literally the building blocks for NAD. So the idea was, okay, these are stable orally, you can take them, they will get into the blood, and then they will also get taken up by cells. So the idea is, if your NAD has gone down, give your body more of the raw material that it needs, and hopefully it will make more NAD. But again, we now know the reason NAD goes down is because those NAD production pathways have declined. We know that inflammatory processes are wasting NAD. And again, NMN and NR precursors simply ignore this, and they don't actually fix those issues.
Okay, so you could take the NMN and NR, and they're precursors, but they're not going to help with that, like recycling and what's actually going on at the cellular level.
Yeah. So whenever anything declines, there's usually a reason.
Yeah.
And we know the reason NAD declines is because of that recycling enzyme, that NAD production pathway that makes all of our NAD when we're young so well, and also the inflammatory processes that are just degrading NAD like there's no tomorrow. So by putting more precursor in, it's not going to help it. And I always say, get people to think of the cell as like an NAD producing factory. Okay? If you had this factory and you were like, oh, my NAD production has gone down, I better go inside the factory and have a look what is going on. And you go in and you see that the machines are broken, the pipes are leaking, and you're like, oh, well, let's ignore all that and let's just ship in more raw material and hope that we get more NAD out the other end. You'd be like, no, that's a stupid idea. What you need to do is fix the factory, because one day the factory used to be very good at making NAD. It's just declined. So if you can fix all that up, you don't need to put any more raw material in. It'll start making it again a youthful efficiency that it once used to.
And well, this is obviously the same for the injectable, because you can buy the raw, like just NAD, and then reconstitute it and inject it into your like subcutaneous.
Yeah,
Still
exactly
the same. Yeah, exactly the same.
So IVs, sub-Q, the purpose of both of those is because you can't take pure NAD orally. So it's bypassing the gut and putting it straight in the blood. But again, IV and getting it in via an IV or a subcutaneous into the blood is not getting it into the cells where it's actually needed.
Yes. Okay. But if we fixed the machinery and supported that and then injected or did an IV, would that work well together?
Yeah, so technically it would.
Okay.
There's still a limitation that an IV can only get into certain cells.
Right.
So at the moment, the research shows that the only cells that have channels big enough to let the NAD, the full NAD size in from an IV or a sub-Q, are the heart cells and the brain cells.
Okay.
So that's missing out an awful lot of other cells,
yes,
which also all need to rely on NAD. So I absolutely think the IVs, have their place. I think neurological conditions, things like that, there's very good anecdotal evidence that they do work. I say anecdotal because there's not a lot of clinical studies on it. But if you can get some NAD, say, into the neuronal cells, but then also when that NAD goes in, have a fully functioning pathway that can then keep recycling and reusing it, you're going to get a way better benefit than you are by putting it into a cell that's going to use it once and then be like, oh, I can't recycle this, I need to get rid of it. Or actually you're putting NAD into the cell where there's loads of inflammation, and the NAD is going to get used for driving inflammation rather than fixing things, which is definitely not what you want.
Right. So all of this information, like, you obviously really have researched this. And so is that what inspired you? Like, after you found out all of this information about NAD and how it works, is that what inspired you to go, oh my gosh, I have to create a product that is going to fix the machinery, we'll say?
Yeah. So my background is actually in drug development, not supplements.
Yeah, I know. That's so interesting.
Yeah, so my role in drug development was developing drugs to slow cellular aging. This is where I first learned about NAD and its benefits. And a couple of things really frustrated me about drug development. The first was that it takes a very long time. So all of this really cool science that we're learning about cellular aging, it's going to be a very long time before people actually benefit. The average person can actually benefit from it. The second thing is a lot of molecules that seem to work really well at fixing some of these issues to do with NAD were not drug molecules. They were natural molecules that drugs companies were absolutely not interested in because they couldn't patent and own them. Therefore, a big amount of the time, they'd put all the money into something that worked half as well. So for me, I was just like, this ethically does not sit right with me. Commercially, I get it, but look at all this research that could be put into something like a supplement. So I founded Nuchido Laboratories back in 2017, and our first mission was like, we have seen the power of NAD in all of the studies. We can see that there are now supplements and, people are trying to boost it using various different things like the IVs, the NMN, the NR. But if you look at all the latest science, which is what I was studying in the drug development world, none of these products that are available are actually fixing the root causes of NAD decline. They're completely ignoring all the latest science, and they're basically based on old science. So we were like, how can we develop something based on the latest science? So that is why we started looking at what we would call a second generation NAD booster. It doesn't put the precursors in, it doesn't put the NAD in, it's got no NAD in it. It actually has a range of different ingredients that are acting on all of the little points in the cell that are going wrong with age to cause NAD decline.
Wow. Can you tell us a little bit about the ingredients and why those things?
Yeah, absolutely. So, well, the number one thing is everyone looks at the back and goes, it doesn't have NAD in it. Like, what?
Yeah,
Why?
yeah.
But hopefully by now everyone will understand why it doesn't have NAD. It's actually, so it's a botanical blend of many different ingredients. The first ones to point out is we've got a couple of different ingredients in there that are designed to switch back on that NAMPT enzyme. So one of them is something called rutin, and that contains an active ingredient called quercetin. And quercetin is known to activate this NAMPT enzyme. Another ingredient that we use for this purpose is called alpha lipoic acid. And what that does is it actually triggers that energy stress pathway that we were talking about, the same pathway that fasting and exercise triggers, but it mimics it and it activates that pathway, which again switches back on the NAMPT enzyme. And we've actually done a clinical trial on our product. When I started this company, I was very, very shocked coming from the drugs world at how many supplements had any clinical research on them. So we were very passionate about doing trials on the product. So we did a double-blind, placebo-controlled crossover study, which is like a gold standard as far as clinical trials are concerned.
Yeah.
And we found that in just 28 days, we significantly increased the levels of this key enzyme in all of the participants. So there were 28 participants. So we're the only supplement that's actually been proven in a human clinical trial to actually fix the root cause of NAD decline.
Wow. That's amazing.
So, yeah, so
Good
that's
for
those
you.
two. Yeah, no, it's been a lot of hard work.
Oh my gosh, yeah.
But yeah, so that's those ingredients. We've also got ingredients in there that are doing other things. So as we mentioned, we've got in older cells, there's a lot of inflammation, which is driving NAD decline. A particular protein or enzyme inside of our cell that causes all this is something called CD38. And basically, for every one cycle of this inflammatory process, it uses 100 molecules of NAD. So it massively depletes our NAD. But if you can inhibit it just a little bit, you can massively increase NAD. So we use parsley powder. So a lot of people go, parsley, like what? But the reason for this is because it's got a powerful compound in it called apigenin. And apigenin is a great inhibitor of CD38, so this inflammatory process. I'm a big fan of using a lot of these compounds or molecules in their natural form. A lot of people think it's better to strip the active ingredient out of the natural product and give it pure, but actually most of those molecules are very unstable and they don't survive well through our gut. It's much better to give a lot of active ingredients that are derived from plant material as the actual plant material, because it protects them through the gut, and then the active is cleaved off when it actually gets into the blood and into the cells. So I think that's an important thing to point out. Yes. Another ingredient is green tea. So that's got a powerful compound in there called EGCG. And if I could count the number of times that I've seen that come up in drug screening tests, working much better than any of the drugs, quite a few times. But the reason that is in our product is it actually it inhibits the methylation process. So I briefly discussed the fact that if our recycling of NAD is not working well in our cells, what happens is the precursors build up and they have to be methylated and excreted. So in older cells that have got a lot of NAD dysfunction, what you see is increased methylation enzymes. So this EGCG from green tea works to inhibit those processes.
Wow. Have you guys done biological testing before and after taking it?
Yes, we have.
And biological testing, just so
biological age,
biological age and chronological age. Chronological is actually how many years have you been here on Earth, and biological is how are you aging on the inside. Is that the best way to explain
exactly
it?
that?
Okay.
That saves me explaining it. It's exactly that. And our biological age is a much better predictor of our future health than our chronological age. So as part of our clinical trial, I mean, I guess I probably should mention, we also measured NAD levels in our clinical trial and showed that went up. That's important.
Okay, good. Yeah.
We measured inflammation and that went down. We measured glycation, which is a biomarker of aging as well, and that also decreased. But biological age was the thing that I was most excited about, because what we found was that in just 28 days, on average, across all of the participants, we reduced biological age by 1.26 years.
Wow, in 28 days.
In 28 days. So we're now doing some longer studies now over longer periods, but we're really excited because if we can do that in a month, essentially, it does just show the power of NAD at the cellular level. So yeah, it was very exciting for us.
Yes.
So all of this research I just spoke about is actually being submitted for publication for a peer-reviewed journal as well. So it'll be available.
Amazing.
To read.
And menopausal women, when we start to lose the hormones, what does the biological age, what starts to happen there?
Oh, yes. So biological age is something that is really impacted, unfortunately, when a woman transitions through the menopause. So studies have been showing that basically, as you go through from perimenopause to menopause, so that rapid decline in hormones, in just 6 months, a woman's biological age can increase by 9 years. So
that's insane.
Is huge. And and this explains why a lot of women literally say, I feel like I've aged 10 years in like that. So this is one of the main reasons why. We know that menopause seems to massively speed up biological aging because estrogen especially is a powerful regulator of a woman's immune system and inflammation.
Yes. Yeah.
And it seems that as estrogen goes down, our immune systems become chronically overactivated. So we've got a lot of inflammation going on in the background all the time that we shouldn't have. And chronic inflammation, again, is a hallmark of aging. So estrogen goes down, inflammation goes up, biological age also goes up, unfortunately.
And I am trying to be very specific with my audience about what estrogen we're talking about. And that is estradiol, everybody. That's the one that drives that rapid aging and the effects on our immune system from estradiol going down, which is the main estrogen in our fertile years that we produce.
Yeah, that's a good thing to point out. 100%.
Yeah, because estrone is more inflammatory, and then estriol is a very weak one that there's some evidence showing that maybe it suppresses our innate immune system. So estradiol, everybody, estradiol. Yeah.
Get it
That's
right.
crazy.
100%.
So I so badly want to do a test for my biological age. And then, because I just interviewed Nat Nidham about bioregulator peptides and how that can reverse biological aging. And I'd just be so interested to see what, like, if taking your product, take it before and then take it after and see has my age come down, and then do it with the peptide. Like, I would love to just start testing this out, because really, like I said in the beginning, we're all looking for this, like, what could help us to slow down our aging process, because it really accelerates during these years. And now we know why. Like, a lot of it has
Yeah.
to do with that. So
Yeah. So I think when it comes to menopause, the best results that we get are actually in perimenopausal and menopausal women.
wow.
Now, when we started, it hadn't actually crossed our minds how much of an impact it would have on this population. But we started getting so much customer feedback saying, oh my goodness, my brain fog was terrible. Now it's gone, my energy, my sleep. And actually, it makes total sense, because if you think about it, right at a time in a woman's life when their hormones are plummeting, their NAD is also plummeting. And a lot of the roles of their hormones and NAD are quite similar. So things like controlling inflammation, like energy production, we know that both play a massive role in energy production in the mitochondria. So this is like, two things coming head on. So no wonder, even if you can just get your NAD levels up a bit, it actually has a major benefit on the symptoms. So this is why we seem to get so much positive feedback. And then the biological age piece of the puzzle, just sealed the deal. We're like, okay, it
Yeah.
really is fixing everything at a cellular level.
Do we know of if any of the hormones help with production of NAD, or any of the processes in there? Besides, is it just that it just helps to lower inflammation, and inflammation drains NAD?
Yeah, it's
Yeah,
not that
kind of
it's having
synergistic.
like an impact directly
Mhm.
on any of the hormones. It's basically doing a lot of the same processes, but from a completely different angle. Which is why actually people that are combining hormone replacement with NAD, you get double the power in the results, because they're acting via different pathways. So
Wow.
it's an additive effect.
And one of the biggest complaints that I hear from my women is that they have no energy, that they're just like,
Yeah.
oh my God, like, what happened? I'm living in a fog. I have no energy. I can't exercise. So I just think that this would be such an incredible addition to the toolkit of these years, and to
Yeah.
continue taking it till the day you die. Do you have to take a break from the supplement?
No, so everything that it's designed to do is to basically keep getting rid of that inflammation, keep dealing with all the issues that our cells are trying to overcome on a daily basis to keep NAD production high. So we just recommend continuing to take it in our study. It was what we would call a crossover study. So often what happens in clinical trials is, if you had 28 people on the trial, you would split them into two groups of 14. 14 would take the placebo and 14 would take the real thing. But what we did was a crossover, which means that everyone takes both. So half of them will have started on the real thing, then had a washout, and then done the placebo. The other half will have started on the placebo, then had a washout, and then it swaps. So what we saw actually in the people that were who did the real thing first and then had a washout is that after a month's washout, levels of the enzyme do start to drop off again, and
Okay.
NAD does go back down to baseline. So yeah, it is something that seems to need to be keep getting activated.
Okay, that's good to know. Like, because you got to keep at it. It's not a quick fix where, okay, take the supplement for a month and your NAD stores are great for a year. You got to
Yeah.
continue with it to get the effects of it.
Yeah.
What have you heard as far as reports of what it has helped with? I heard on Zora's podcast, a guy came on that was listening. It was like a webinar, and he was saying that he had taken it for a year, and he was in his 70s, I think. And he said, I can exercise now. He said, I couldn't before. He said, I was always so tired. And he said, now I'm working out. And he said, he just went on and on about how great your product was. And he did test his biological age, and his went down. I can't remember how many years, but it did change. his biological age.
Yeah, I mean, number one is energy,
Yeah.
you know, and that's across the board. I know we've obviously spoken a lot about women, but men and women, you know, have a huge impact on energy levels, and it's not just physical energy; it's that cognitive energy as well. So not only feeling, a lot of people describe it as not like a caffeine energy where you're just like jittery. It's more like oh, you know, I've got loads of, you know, get up and go today and I just want to get on with things, and like, what can we, you know, really enthusiastic energy. That's kind of the sort of words that our customers use. So that physical energy, that cognitive function, you know, getting rid of brain fog. Sleep is probably the third thing. So we briefly touched upon the fact that NADs is very important in our circadian rhythm, which is our 24-hour sleep-wake cycle. That doesn't just control our sleep, but actually controls all our hormones, our metabolism, everything on this 24-hour rhythm. And NAD is a very critical molecule that actually switches on and off a lot of the genes that control this 24-hour rhythm. So what we see is that in people who are older and have lower NAD, the circadian rhythm becomes less pronounced. So it like flattens and it's not as strong. And this is, you know, very linked with the reason why older people don't seem to sleep as well. They don't sleep for as long. Our metabolism's going down. You know, that influence of NAD on having that nice, strong circadian rhythm on a 24-hour cycle. So sleep is a big one. We have a lot of customers that have like Oura rings and Whoop bands who are measuring their HRV and the sleep quality. So again, it's like, it's not just people going, oh, I think I had a better sleep. They're like, look at my data.
Yeah.
You can see it. So I'd say those are our top three. More longer term things. So some of those things, you know, people can notice pretty quickly depending on how depleted they are. More long term, hair, skin, and nails are a huge one. Now I don't get as excited by these. I'm more as excited by like biological age and switching on genes.
That's because you're young.
Well, no, I'm just a total science geek. That's why. But hair, skin, and nails. So their skin quality, nails. So we always joke about Nuchido nails, people's nails growing really long and strong. Hair color, reversal of gray hair, all things that you know, our customers report back.
Wow.
Yeah, one of the studies we're running at the minute is measuring sleep quality. Because again, we don't just want anecdotal evidence, we want some real data.
Yeah, I like that you're trying to get the science to back it all up, which is, I think, so important nowadays. There's so many supplements out there, so many claims, that if you can have studies to back it up, I think it really, really helps people to feel more secure about purchasing the product, for sure.
Yeah, absolutely.
Well, I want better sleep. I want better hair, skin, and nails. I want more energy. So I plan to try the product, and I will let everybody know what I think of it, which I think is going to be good. So I already can tell. I'm going to love it. Yes. And so we have a discount code for the listeners if they would like to try it. And that is KM20, and that will get you 20% off your purchase. And that's capital KM20, which I will link to everything in the show notes. You can get it. It's available in the UK, correct? Because you're in the UK?
It's available worldwide from our website.
Okay.
Yeah.
Perfect. So you can, no matter where you are, you can give it a try. So be sure to check it out. Let us know. I always want to know, like, did you try it? How did it work? It's great because I'll have people that will come to me like 6 months after I did an interview with somebody, be like, oh my gosh, I tried this product and it was so great. So I like to hear about, you know, what your results have been. So be sure to, you know, hit me on Instagram or Facebook, wherever you want, but let me know how it worked for you. So I think this is a great supplement that is going to really help, probably, like you said, perimenopausal and menopausal women were your biggest like cheerleaders for the product. That's so cool. Well, thank you very much for coming on the show. I appreciate it. It's been very enlightening. You are one smart cookie, and I love everything that you're doing. So keep doing it.
Oh, thank you so much. That was a great chat. Yeah, anyone has any questions, they can certainly come and find me, and I'll be more than happy to chat.
Yes, and maybe just say the website. I am going to link to it so you guys can find it, but just so they hear it in case they're driving.
Yeah, so our website is nuchido.com. So that's nuchido.com. And if you want to follow us on social, it would be at Nuchido or at Dr. Nichola Conlon for lots of more geeky science stuff.
I love the geeky science stuff. All right. Thank you so much.
You are welcome. Thank you.